Ever wondered if you could hold a personal storm tracker right in the palm of your hand? You know, a little gadget that could warn you about lightning before you even hear the thunder? Well, today, we're going to do just that. We're going to deconstruct the exact code that makes it possible, showing how it takes a raw electrical signal right out of the air and turns it into a smart, life-saving alert.
So, here's the big question. Can a few lines of code, a simple script, really tell the difference between a distant, harmless storm and a real nearby threat? The answer is a big, resounding yes. And the secret, well, it's all in how the code is designed to listen, to think, and then to act. Let's see how it actually works.
So, in this explainer, we're basically pulling back the curtain on the software for a smart, Wi-Fi connected lightning detector. We're going to follow the logic step by step, from the very first moment an electrical event is sensed, all the way to an alert popping up on your screen and a data point shooting off to the internet. All right, first things first, how does this little device even know a storm is brewing? Well, it all starts with a very specialized sensor, the AS3935. The easiest way to think about it is like the device's ears. It's just constantly listening for the very specific radio frequency chatter that a lightning strike gives off. Now, what's really cool is how the sensor gets the main processor's attention. It uses something called an interrupt, and it's basically like a tap on the shoulder for the processor, saying, hey, stop what you're doing right now. I've got something important. This is so much more efficient than the processor constantly having to ask the sensor, anything yet? How about now? Using an interrupt means you get an instant reaction every single time. The whole process is really just this simple three-step dance. First, the sensor detects, well, something, an electrical event. Second, it sends that tap on the shoulder signal through a physical pin. And third, the software wakes up and basically asks, okay, what was that all about? And this is where the code gets really smart. After that interrupt, it reads a value to figure out what actually caused it. It uses this simple if-else logic you see right here. Was that interrupt caused by actual lightning? Or was it what's called a disturber, like a nearby microwave oven turning on? Or was it just some random background electrical noise? The code sifts through these possibilities to find the real signal. Okay, so once the code confirms, yep, that was lightning, the device's brain, the processor, kicks into high gear. It's not just about detection anymore. Now it's all about turning that raw event into useful, actionable information. And in just a split second, the software does a whole cascade of things. It bumps up a strike counter, it calculates how far away the storm is, it timestamps the event, and it logs everything into a history file. See, it's not just detecting a single event, it's building a complete story of the storm as it develops. And this single line of code right here, this is where the magic really happens. That lightning.distance-to-storm function is what takes the raw, kind of abstract sensor data and turns it into a number we can all understand. The distance to the storm, in kilometers. This is the exact moment an invisible event becomes tangible data. Pretty cool, right? But here's the thing. This data isn't just for you. This is a true Internet of Things device, and it's designed to share what it learns. So how does it talk to the rest of the world? Well, it hops on your Wi-Fi and sends its data up to the cloud. There's a function called send lightning data that basically acts as the device's voice. It gathers up all that key information, the distance, the strike count, the time, and bundles it all up for its journey out to the internet. Now, the data isn't just sent out randomly. It gets packaged up all neat and tidy into what's called a JSON payload. As you can see, it's kind of like a digital postcard. It's got these clearly labeled fields for everything, from the lightning distance to the device's current settings. This makes it super easy for any server out there to read and understand it. And where does that digital postcard actually get sent? Right here, to this web address. This one line of code is what connects this little device to a global network. Every single time lightning is detected, its data gets sent right to this URL, contributing to a much bigger picture of storm activity. Okay, so the device has sensed the storm and it's told the internet. But what about the most important person in this whole equation? You. Let's look at how the code translates all this data into clear, unmissable warnings. The most direct alert is, of course, right there on the device's little screen. A function called display lightning event takes that distance data and formats it into this simple, easy-to-read message. No fluff, no confusion, just the critical information you need to know right now. For a quicker, at-a-glance warning, the code also controls a little RGB LED, and the logic here is just beautifully simple. A function called set RGB color for distance just checks the distance. If it's close,
say less than 10 kilometers, the light turns red for a high alert. A bit further away, it's yellow or green. It's an instant visual threat assessment.
The device is also interactive, which is great, but what's really clever is how the code uses a single button to do two totally different things. A function called check button press doesn't just see if the button is pressed, it actually measures how long you hold it down. A quick tap changes the sensor mode from indoor to outdoor, but a long press, holding it for more than a second, toggles the audible alarm on or off. Now that's some efficient coding.
So we've seen all the individual pieces, right? The sensing, the processing, the communicating, and the alerting. Now let's just step back for a second and see how all these parts come together to create one continuous, elegant system.
This right here is the entire journey. It starts with a physical event happening in the atmosphere and ends with a shared piece of data online, all in a fraction of a second. As this shows, every single step is a distinct software function, and they all work in perfect harmony to create a smart, responsive device.
And the engine that drives all of this is the main loop function. You can think of it as the device's heartbeat. It just runs over and over and over thousands of times per second, constantly checking for lightning, checking for button presses, checking the Wi-Fi status. This loop is what keeps the device awake, aware, and ready to react at a moment's notice.
You know, when you get right down to it, this isn't just about lightning. This code is really a blueprint for taking any invisible event from the physical world, translating it into data, and then sharing it. So it makes you wonder, what other invisible forces are out there right in your world that you could bring to life with a sensor, a bit of code, and a screen?